this video on graphing linear inequalities. By the end of this video, you should be able to determine if a point is a solution to a linear inequality. You should be able to determine when you should use a dotted or solid line to graph your inequality, and you should be able to determine whether you shade above or below the line to represent your inequality solution area. So let's get started. In our first example here, I ask to determine which of the ordered pairs are solutions to the linear inequality. Now, a solution is when you plug these values in, it makes the inequality true. So if it was graphed, it'd be in the shaded area. So let's take a look. So this is a coordinate point. The 2 is an x value, and the 5 is a y value. On each of these, the first value is always an x, and the second is a y. What we're going to do is we're going to take these individually, and we're going to plug them into this inequality to determine if the inequality is if this statement is true with those numbers plugged in. So 2x minus 3y needs to be less than 15. So x in this case is 2, and y is 5. So instead of 2 with an x, we now know that x is 2, so I'm going to plug in 2. Then it says minus 3y, well y is 5, and that side needs to be less than 15. So let's check it out. 2 times 2 is 4, negative 3 times 5 is negative 15, and I still need it to be less than 15. 4 minus 15 is negative 11, and negative 11 is less than 15, so the point 25 is a solution. Okay, that means if it was graphed, it'd be in the shaded region. So let's try it again. So now my x value is negative 1 and my y value is negative 7. So I'm going to plug them in. 2x, x is negative 1, minus 3y, and y is negative 7, has to be less than 15. 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21, and I need that to be less than 15 if it's going to be a solution. Well, negative 2 plus 21 is 19. 19 is not less than 15. So the point negative 1, negative 7 is not a solution. Okay, try it again. The point 3, 4. So 2x is 3, minus 3 and y is 4. I would need that side to be less than 15 for 3, 4 to be a solution. 2 times 3 is 6. Negative 3 times 4 is negative 12, and I still need it to be less than 15. 6 minus 12 is negative 6. Negative 6 is less than 15, so the point 3, 4 is a solution. All right, let's try one last point to see if it's a solution or not. 0, 0. This is the easiest one. 2 times 0 minus 3 times 0, and I would need that to be less than 15. 2 times 0 is 0. Negative 3 times 0 is 0. Well, definitely 0 is less than 15. So 0, 0 is a solution. Okay, so we've graphed lines, and this is going to be the same idea. We're graphing lines, but because they're inequalities, there's a couple things that we want to remember. Whenever we're graphing our lines, we like to put them into slope-intercept form. Just makes it easier to graph the intercept and count the slope. One thing I want to mention here, be very careful. Remember to change the direction of your inequality when you divide or multiply by a negative. So remember to flip the inequality when you multiply or divide by a negative number. Okay. So here's the rules when we're graphing with inequalities. If I have a less than or a greater than, meaning the not equal to symbols, we're going to use a dotted line. When we graphed our one variable inequalities, that'd be the same as using an open circle. So we would, instead of drawing a connected line, we're going to draw a dotted line. If our inequality symbols have equals to under them, we're going to use our regular solid line that we've been using all along. That'd be the same as when we used a closed-in circle. It's kind of like shading in the line to include the line as part of the solution. So that'd be just a regular line. Now, because inequalities can have more than one answer, we shade in where the solution could be. If your symbols are greater than or equal to or greater than, these are greater than symbols, you will shade above the line. If you have a less than or equal to or a less than, you're going to shade below the line. Now, one way to determine if you're having trouble deciding where you need to shade, especially if the line is particularly steep, one thing you can do is use a test point to plug in, similar to what we just did up here, to plug in to determine whether you should shade, which side you should shade on. I almost always use 0, 0 if I'm going to use a test point, because remember how easy this one is because everything canceled out to a 0. And so you could see if it's a solution or not. If it's not a solution, you'd shade on the other side of the line. If it is a solution, you'd shade on that same side. And then all the points in the shaded area are solutions to the inequality. Any one of the ones in the shaded area would make the inequality statement true, like we were checking out up here. All right, so let's go ahead and try some of these. Now, I'm giving this to you in standard form, so as we have been in the past, we're going to put this into slope-intercept form, which means y has to be alone. So this is a negative 4x. I'm going to add 4x to both sides of the inequality. So y is less than or equal to 4x minus 3. So my slope here is 4. You can write it over the 1 to help you think about your graphing. My y-intercept is at negative 3. Now remember, there's a couple other things we got to pay attention to. We have to look at what kind of line do we need to draw and what kind of shading do we need to do. This inequality is an equal to inequality, so that means when we draw this, we're going to draw a solid line. And it's less than means shade below. Okay, so let's try this. We graph these exactly the same. We're going to start at negative 3. So 1, 2, 3 down from the origin. And then our slope, that's a positive 4. That's a y value. So we're going to go up 4 and the x is positive. So positive x's are to the right. So 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Every time you finish your count, drop a new point. If you want to extend it the other way, we went up and right, so we'll go down and left. 1, 2, 3, 4, left 1. Okay, we're going to use a solid line, so we're going to connect our points and put arrows on the end. Okay. Now, we need to shade below the line. This is a pretty steep line. It's a little hard to see above or below. We could use a test point. Another thing that works really well is look at your y-axis right here. But from this point, where's below this point? Because we need to be less than. Below is in this area, so everything on this side of the graph can be a solution. Any point in the shaded region and any point on the line, if we plug them in, makes the inequality true. Okay. If this was a dotted line, none of the points on the line would work because it can't be equal to, but any of the points that were in the shaded region would work. Let's try another one of these and see how you're doing. All right, so this one is nice. It's already in slope-intercept form. So when we look at this, we see that the x is up in the numerator, but remember that's a -1 in front of that. So my slope is -1 divided by 2. And then my y-intercept, so we're going to start counting at +6. Remember, these are inequalities, so we need to pay attention. Our inequality symbol does not have an equal to, so we're going to have a dotted line. And this is shade greater than, so we're going to shade above the line. All right, so let's go ahead and start. We're going to start counting at where y is +6. 1, 2, 3, 4, 5, 6. Drop your point. Now our slope, the top number is negative. That means we're going to go down 1, and the 2 is positive, and x values go right when positive. So down 1, right 2. Down 1, right 2. And get some points on there to help. It makes it, the more points you have, the easier it is to graph. So we went down and right, up and left will give us the exact opposite. Okay, remember, dotted line, not solid. So when I come in here, I'm just going to not make it solid. I'm going to draw a dashed line. Okay, so it's not connected together. Now, we need to shade above the line, above the points. So look at any of the points. You want to look above them in this case. So greater than the line is up here. It's a little easier to see when the line's not quite so steep. All right, let's take a look at another one. So on our next one, we're back into standard form again, which means we need to put this in slope-intercept form so we can graph it easier. We're trying to get the y alone. The y is locked up in this term right now, and there's 2 terms on this side, so we need to move the 3x out of the way so we can get into where the y is. That's a positive 3x, so our opposite operations say to subtract 3x. 3x minus 3x cancels to 0, and that's going to leave me -2y on the left. Then we have a greater than or equal to sign, -3x minus 4. Now we need to get y by itself, so we're going to divide by -2. We just divided by a negative number. Remember, if you multiply or divide by a negative number, it changes the direction of your inequality. So I'm going to change the direction of my inequality and simplify. -2 divided by -2 cancels to a +1, leaving y. -3 divided by -2. I'm not going to get a whole number if I do that division, so I'm going to leave it as a fraction. And this fraction is already as simple as it can get, so it's going to stay 3/2, and it is going to be positive because I have a negative divided by a negative. 3 divided by 2x. Then I have -4 divided by -2 becomes +2. So my slope here is 3/2. My y-intercept is 2. I have an equal to symbol on my inequality, so I want to use a solid line. And it's a less than, and less than means shade below the line. All right, so now we're going to graph it. Where y-intercept is 2, so let's go to where y is 2 and put our first point. Our slope is a +3 over a +2, so +3 for y's means go up, +2 for x's means go right. So we're going to go up 1, 2, 3, right 2. 1, 2, 3, right 2. I'm going to put a couple more lines going down and left. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay. All right, solid line. So that's what we're used to making. And we want to shade below the line. Pick any point. It really doesn't matter which point you pick. You want to shade below it. So we're shading on this side of the graph. Any point in the shaded area when plugged in will make the inequality true, including any point on the line. If we looked at this one up here, any point in the shaded region, if we plugged it in, will make the inequality true, but we cannot use any point that's on the line because they're not included in the solution. That's why it's dotted. It's not shaded in. All right, one last one. This one's a little on the tricky side. Take a look what we've got here. We have x is greater than 4y minus 8. Remember, slope-intercept form is y equals mx plus b. We need y alone, not x alone. So what we need to do is work on getting y alone. Here's y. It's tied up. There's two terms over here. So what I want to do is I want to add 8 to both sides. So I have x plus 8 is greater than 4y. To get y alone, I'm going to divide every term by 4. Remember, there's a 1 in front of the x. So I have 1 divided by 4x. 8 divided by 4 is 2, is greater than y. I'm going to turn this around to make it a little bit easier. I'm going to have it start with y because you guys tend to do better when it's that way. See how the small side is pointing to the y? Make sure it's still pointing towards the y. And then we have 1/4 x plus 2. Okay, so my slope here is 1/4. My y-intercept is 2. I do not have an equal to sign on there, so I have a dotted line. And it says less than, so that means I'm going to shade below. All right. So let's go ahead and do this. We start at where y is 2. And our slope, the y value is positive, so that means go up. My x value is positive, so that means go right. Up 1, run 4, 2, 3, 4. Up 1, 1, 2, 3, 4. And we're out of room, so I'm going to do a couple going the other way to help me. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Okay. Now that we've gotten that on our graph, we're going to have a dotted line. So remember, that means we're not going to make it a solid because the points on this line would not make the inequality true. That's just a visual reminder that the points on the line will not make the inequality true. And we had less than, so that means shade below. That means below the points. So here's my points. I want to shade below them. So this is my solution area. So any point in the shaded area makes the inequality true, but not any of the points that are on the line. Hopefully this was helpful. Let me know if you have any questions. See you in class.